sorry, this is n here, n must be greater than 0. Here 1 minus n means if it is positive then less than 1, no doubt, but 1 minus some positive value, and positive value means less than 1, then it will be less than 1, and if mu is less than 1 then n must be positive value, it cannot be negative. If it is negative, then negative positive, then it will be more than 1. So this value will be added, then mu will be greater than 1, but it must be less than 1, only then the function is convergent. For convergency of this function, n must be positive. So hence, n is greater than 0, only then the function is convergent. Only then the given function is convergent by mu test. Is convergent by mu test. Here, by mu test is convergent only when n is positive. Okay, this is what you call 9th question. Now let me talk about 10th question. All these questions I am talking about one by one. This is the convergency of improper integrals. How functions are convergent by improper integrals, or of improper integrals are convergent. Let me clean this. So convergency of improper integrals we are talking about with the help of test, Abel test, mu test, quotient test, okay, Dirichlet's test, etc. So all these tests are defined up to now. So please go through all these questions, and if improper integrals are being asked about, what are these tests I've talked about? Just clarification of the questions is my main objective. That student must know what are these tests and how these questions are solved. Okay, all these questions are taken from students' queries. All these students' queries which are taken here, I'm defining that how they are solved. Now, question number 10. Test the convergence of now e raised to power minus x again. Actually, for this is 0 to infinity. Okay, so 0 to infinity, let me define. 10th question. Now in this case, 0 to infinity it is e raised to power minus x, x raised to power n minus 1. Previously it was, okay, 0 to 1 only, okay, x tend to 0. Now we'll take the 2 points here, 1, 2, let me take 0 to 1, let me divide this. Okay, let us divide this function, or write this function as 0 to 1. This is e raised to power minus x, x raised to power n minus 1 into dx plus 1 to infinity. This is e raised to power minus x, x raised to power n minus 1 into dx. Now these are defined in the first part. This is convergent. This is the first part is. This is the first part is convergent, as I defined in the 9th question. Is convergent, okay, by mu test for n greater than 0. For n must be positive here, then the function is convergent. The first part is convergent, we have just proved in the 9th question. 10th question is limits are 0 to infinity. Now e minus x actually is for n minus 1 again. For the second part, this one we have to prove 1 to infinity. So if this infinite value extend to infinity, if I take, then I have to talk about x raised power okay, n minus 1 if I take, the extend to infinity. So here e, let me take fx equal to e raised to power minus x is monotonic decreasing function. A monotonic decreasing function. We always say that if limits are a to infinity, and this is first kind of improper integral, this function is finite. I mean, this is bounded. So monotonic decreasing and hence bounded, and hence bounded. Within this limit 1 to infinity, if I put here infinity to 0, at x tend to infinity it is 0, e raised to power minus x, okay, or it is infinity in that situation, that it will be, the final value it is infinity, but within this limit 1 to infinity it will be finite. At one or 2 points if it is bound, the function is convergent. Okay, that's whatever limits are given, then the function is convergent. So this is monotonic decreasing and hence bounded. Okay, because at 1 or 2 points, or at number of points within 1 to infinity, it will be bounded. It will be finite value. There will be value will exist between this. If I express this e raised to power minus x as 1 upon e raised to power x, then express this 1 plus x square upon factorial 2 plus x cube upon factorial 3 and so on. And if I substitute x tend to 1 to, more than 1 values, or even at 1, there will be some value. It will exist. There will be some finite values within this limit 1 to infinity. It means the function is convergent. Hence, the function is decreasing undoubtedly, because it is 1 upon x something, the value is increasing. The function is decreasing, monotonic decreasing, but the value will be finite. Some values are finite within this limit. At infinity only, the function will be infinite, because it is 1 upon 0. I put x equals 0, but the first term is 1. 1 upon 0, 0 is okay. That is 0. Infinity is 0. So 1.1, this is 1 there. I'm sorry, even at infinity, the value will be 1. So this is equal to 1. Because limit x tend to infinity, e raised to power minus x is equal to 1. If I express this 1 upon ex, ex is 1 plus something, 1 plus x squared, x is then infinity. Okay, that is 1 upon 0. So it is 0 in that situation, or it will be 0 then. But at infinity only it is 0. Okay, now before that it is, because x is 1.0, 1.0, 1.0, it is 0 upon something, 0. Okay, so that is what you call 0 only. Right at infinity, when x tends to infinity, this is infinity here, the last limit. At last limit it is 0, but before that the function is finite, the value will exist, and this part is continuous function. Okay, so when a part of this is continuous or bounded, let me talk about the second part, x raised to power n minus 1. So a new test will limit x tend to infinity. This is x raised to power mu into x raised to power n minus 1 into fx. If I take fx here is this ex and this power 1. Okay, then this is equal to x raised to power mu plus n minus 1. And if I take this is limit x tend to 0, this whole function fx, if I take, let me take this function is fx completely. It will be 1, that means x raised to power 0, that means mu plus n minus 1 equal to 0. Or here again, mu is equal to 1 minus n. Mu is equal to 1 minus n. So in that situation, n is positive. Okay, so mu must be less than 1, for that n must be positive. And this part is also finite. This is also convergent. Part of this is convergent, hence the whole function is convergent. 10th question is done. That's the convergence of this function. Hence, this function is convergent in both the bases. Hence, this function is convergent, or to say, this function is convergent here by mu test. Hence, by mu test, this function is convergent for n greater than 0. N is positive, only then this function will be convergent. Okay, so this is what you call 10th question we have done. Now, the remaining questions I'll take after 5 minutes break. Okay, because I'm tired now. So, after 5 minutes break, I'll take the remaining questions. So, this 10th question is convergent by mu test. 10th question we have done. 11th up to 16th. I'll do after 5 minutes break for the friend. Okay then. 10th, 11th question is discuss the convergence of this. Okay, no problem. Then all other functions are there that I'll take in the next after 5 minute time. Okay then. See you.